Hello guys, so ito yung continuation of the lesson about maximum and minimum values of a function. So I've already discussed about the first derivative test. So now we have the second derivative test, wherein this test will be used also to identify whether our critical values are maximum or the minimum values of the function. So, for the first condition, we have the function y is equal to f of x is a maximum at x equals a if f prime of a is equal to 0 and f double prime of a is less than 0. So, meaning, ang itetest nating value is yung manggagaling ulit dun sa tinatawag nating critical number, which is the value of x that will make our first derivative equal to 0. So, then, kapag kumuha tayo ng second derivative niya, and then sinubstitute natin yung critical number na yon, and then, if it will result to a negative answer, negative value, therefore, you can conclude that it is a maximum value. So, on the other hand, if the function y equals f of x is a minimum at x equals a if f prime of a is equal to 0 and f double prime of a is greater than 0. So, ang parang mas madali dito yung this test is much easier compared kay first derivative, since isa lang yung itetest natin, yung second derivative lang. Kunin lang natin yung value niya, then identify lang natin yung sign. So, we can identify the value if it is the maximum or minimum. So, let's have an example. So, find the value of x for which the function f of x is equal to x cubed minus 6x squared plus 9x minus 3 is a maximum or a minimum. So, our solution would be, first step, we have find the critical values of x. So, dun ulit tayo manggagaling. Kunin natin yung first derivative. So, we have the derivative of x cubed minus 6x squared plus 9x minus 3 is 3x squared minus 12x plus 9. So, naulit lang to. Kinuha natin yung roots nung x. Inequal natin siya sa 0. Therefore, we have the critical values 1 and 3. So, ang may iba lang sa ngayon is yung pag-test. Yung way ng pag-test sa kanya. So, for x equals 1, sure naman tayo na yung at x equals 1, f prime of x is equal to 0. So, doon naman tayo proceed sa second derivative niya. So, from the first derivative, the equation 3x squared minus 12x plus 9, nakuha natin si second derivative, which is equal to 6x minus 12. So, anong gagawin dito? Substitute nyo lang si value ng x natin, which is 1. So, we have negative 6. Thus, we have a negative value of our second derivative. Therefore, ang sinatisfy niyang condition is yung first condition. Therefore, we considered x equals 1 as the maximum value of our function. So, same lang yung naging result, diba? Dun sa first derivative test natin, at x equals 1, maximum value rin siya. So, pagdating kay second derivative, same lang yung result. X equals 1 is the maximum value of the function. So, next nating iti-test is the critical value at x equals 3. So, we have the first derivative equal to 0. So, the second derivative, substitute lang natin yung value ng 3. So, we have a positive 6. So, thus, our second derivative is greater than 0, therefore it satisfies the second condition. Hence, we can conclude that the minimum value of the function is at x equals 3. So, mas madali siya, ano? Yan. Wala na ditong mangyayaring overlapping kasi hindi ka naman na mag-a-assume ng values ng x greater than 3 or less than. So, much less yung risk dito. So, our next topic is about point of inflection. So, yung tinatawag daw nating point of inflection is a point where the sense of concavity changes. Kung halimbawa yung, 'di ba, yung graph natin na ganito. So, let's say ito yung x and y axis natin. So, we have ganitong curve. So, kung paano nag-change ng kung saan nag-change ng curvature yung arc natin or yung curve, yun daw yung tinatawag na point of inflection. So, tandaan, iba yung point of inflection sa maximum and minimum values natin. So, paano natin kukunin yung point of inflection? So, we have the point of inflection test. So for our first condition, if f double prime of a is equal to 0, and if for the values, 'di ba, nakuha natin yung value ng a na magpapa-0 dun sa second derivative natin. Pag nag-consider tayo ng value less than a, let's say ang lumabas is, 'di ba, let's say for x less than a, ang lumabas na sagot kay second derivative natin is less than 0. Dapat daw ang lalabas na value kapag x greater than a na yung kinonsider natin, dapat mag-i-interchange yung sign. Therefore, dapat greater than 0 naman siya. So, pwede rin naman na halimbawa, kinonsider mo na x greater than a yung una mong tinest, and then lumabas ay less than 0. Dapat daw, pag sinelect mo naman is x less than a, dapat maging less than naman yung, maging greater than naman yung sagot nung f double prime of a mo. So, dapat, ang point lang dito is mag-interchange yung sign. So, kapag nag-consider ka ng less than a, halimbawa negative yung nakuha mo, dapat pag nag-consider ka naman ng x greater than a, positive naman yung makuha mo. Or, pwede rin naman na nag-consider ka ng x less than a, positive yung nakuha mo. Dapat, pag nag-greater than a ka naman, negative naman yung makuha mo. So, dapat, baliktaran lang. Ganun yun. So, dun sa second condition naman, we have if f of double prime of a or the second derivative of the function equal to 0, dapat daw yung third derivative mo is not equal to 0. Kapag nangyari yon, na-satisfy niya yung condition na to, then y equals f of x has a point of inflection at x equals a. So, ang tanong, dapat ba ma-satisfy niya tong dalawa para ma-considered na point of inflection yung isang point? So, hindi. Kahit isa lang dito yung ma-satisfy niya. So, pwedeng ito lang or pwedeng ito. So, let's have an example. So, find the maximum, minimum, or inflection point of the given curve. So, i-review natin pagkuha ng maximum and minimum point. So, una, 'di ba, pagkuha ng maximum and minimum point ng function natin, kunin muna natin yung critical values. So, manggagaling ulit yung critical values natin dun sa equation ng first derivative. So, we have the equation of our first derivative is 5 minus 5x raised to 4. So, setting this equal to 0, so we have the values or the roots of x are positive 1 and negative 1. And then, itong pangalawang factor niya, 'di ba, magiging imaginary yung sagot. So, hindi natin i-consider yung roots na imaginary. So, we will consider only the real numbers, yung roots na real. So, therefore, ang i-consider natin critical numbers are 1 and negative 1. So, we have to test the values. So, let's say, gamitin natin yung dalawang test. Dun sa, di ba may dalawang critical value tayo, which is, yung una is x equals 1. So, gamitan natin siya ng first derivative test. So, mamaya, yung x equals negative 1 na critical value natin, gagamitan naman natin siya ng second derivative test. So, now, let's consider first the FDT. So, for the FDT, di ba, ito yung mga conditions nating imi-met. So, we have to consider the values of of x that is less than or greater than a. So, for x equal to a, which is x equals 1, so we have y prime is equal to 0. So, paki-erase na lang din, wala itong 5 na to dito, 0 ang sagot dyan. So, for the time naman na kinuha natin yung value na x less than a, ang pinili kong sagot value is x equals 0. X equals 0. So, ulitin ko, bawal tayong mag-overlap kay negative 1. So, dapat hanggang 0 lang. 0 or negative 0.5 or negative 0.99 para hindi mag-overlap dun sa another critical value natin. So, we have x less than a. So, we have positive value of y prime. And then, pag-consider ko naman nung value na x greater than 1, we have 2. So, ang lumabas na sagot for y prime is negative 75. So, therefore, the value of the first derivative is less than 0. Therefore, ano yung sinatisfy niyang condition? So, we have the first condition. So, therefore, kasi 'di ba for x equals a, y prime is equal to 0. So for x less than a, 'di ba ito 'yon, dapat daw y prime is greater than 0. So tama naman. And then for the third condition, x greater than a, dapat y prime is less than 0. So it satisfies the first condition. Thus the maximum value of the function is at x equals 1. So, specifically, to locate this point, ang gawin lang natin is substitute natin yung value na x equals 1 dun sa original equation ng function natin, which is 5x minus x raised to 5. So, we have the value of y equal to 4. So, the maximum point of the function is 1, 4. So, next, we are going to test the critical value wherein x is equal to negative 1. So, dito naman, ginamitan ko naman siya ng second derivative test. So, sabi ko nga, mas madali dito si SDT. Kukunin mo yung equation for the second derivative. So, we have the equation for the first derivative, then i-derive lang natin ulit. Therefore, we have negative 20x cubed. Then, substitute lang natin yung values, which is x equals negative 1. So, for the value of the second derivative, we have 20. So, that is greater than 0. Therefore, it satisfies the second condition. Thus, the function is a minimum at x equals negative 1. Specifically, to locate this point, so we have to substitute the value of x at the original equation. So, we have the minimum point at negative 1, 4. So, dito na tayo sa pagkuha ng point of inflection. So, sa pagkuha ng point of inflection, unang kinonsider ko dito muna, pinakita ko dito si first condition. So, ang kailangan nating i-satisfy is ito. So, una, paano makukuha yung value ng A? Or kumbaga, siya din yung critical number. So, paano yon? Dapat yung value ng A, dapat yung second derivative is mag-equal to 0. So, kumbaga, dun sa maximum and minimum value natin, sineset natin yung first derivative equal to 0, then we solve for the values of x. Ngayon naman, we set the second derivative equation equal to 0, then solve for x. So, we have here the first derivative. So, ang second derivative, negative 20x cubed. Then, i-equal natin siya sa 0. Then, kuhain natin yung roots, which is 0 pagdating dito. So, we get x equals 0. Now, we are going to test this value. So, we have, for the statement 1, dapat magte-test tayo nung value na less than A and then greater than A. So, diba, inuna ko dito yung value na less than A, which is negative 2. So, pag substitute ko dun sa second derivative niya, ang value na nakuha ko is positive. Therefore, dapat, dito hindi ko na bago. X greater than A na to, kasi 5. Greater than 0 naman si 5. Therefore, namali ko lang to. Hindi ko na nabago pag copy-paste. So, dapat x greater than a to. Then, dapat, ang sabi natin to satisfy the first condition, kung ito ay positive sa itaas, kapag nag-change sign din dito, diba less than dito, nag-greater than naman dito, dapat mag-interchange din yung sign. So, positive dito sa taas, sa nauna, therefore, dapat negative sa pangalawa. Therefore, it satisfies the first condition. Therefore, we can conclude that the curve of the function has its point of inflection at x equals 0. So, to find the coordinates of the point of inflection, we have x equals 0. So, substitute lang natin ulit dun sa original equation. We get y equals 0. Therefore, the point of inflection is located at the origin, which is 0, 0 yung coordinate niya. So, how about we are going to test this value in terms ng second statement dun sa point of inflection test. Tingnan natin kung isa-satisfy din niya yung second statement. So, our second statement is ito. If the second derivative of the function is equal to 0 at x equals a, and if f triple prime of a is not equal to 0, then y equals f of x has a point of inflection at x equals a. So, dito naman, kunin natin yung third derivative niya. So, di ba, meron tayong first derivative, nakuha natin si second derivative. So, we will get the third derivative. So, dito, pinakita ko lang ulit yung pagkuha ng critical value, which is yung f double prime of a is equal to 0. So, nakuha natin yung value na x equals 0. So, para ma-test yun, kukunin natin yung third derivative. So, we have the second derivative, negative 20x cubed. So, our third derivative of the function will be equal to negative 60x squared. So, pag sinubstitute natin yung value nung nakuha nating x, ang nangyari, ang nakuha natin is equal siya to 0. Pero, dito, hindi niya sinatisfy na dapat yung third derivative natin is not equal to 0. Pero, dito nag-equal to 0 yung value natin. However, pwede pa rin natin siyang ma-considered as point of inflection dahil sinatisfy niya yung first condition. So, kasi dito, baka ang ibig sabihin lang dito ng third derivative is parang siguro wala na tayong makuhang derivative. So, let's say, 'di ba, katulad ng condition na halimbawa ang second derivative mo, 'di ba, 9. So, kapag kinuha mo yung third derivative nito, automatically 0 na 'to, ano, kasi kahit wala ka nang i-substitute na value, 0, automatically 0 na. Siguro sa ganitong situation, yung ibig sabihin hindi siya wala siyang point of inflection. So, however, dito sa condition na to, although hindi niya sinatisfy yung second condition, nasatisfy naman niya yung first condition, considered pa rin siya as a point of inflection. So, hindi naman kailangan isatisfy niya yung dalawa. So, therefore, kapag kukuha kayo or magtetest kayo ng isang point to determine whether it is a point of inflection or not, so, kahit isang condition nyo lang siya i-test, kahit dun sa first lang, or sa second. So, kapag ginraph natin yung problem, yung function natin na y equals 5x minus x raised to 5, so, ito na yung kalalabasan niya. So, we have the maximum point here, 1, 4, and then the minimum point, negative 1, 4, and then the point of inflection at the origin. So, di ba kasi dito, yung curve natin is concave upward. Tapos, pagdating dito, concave downward na siya. So, dito daw yung nangyari, yung point of inflection. So, yun muna yung lesson natin for this week. Thank you, guys.